Good day, grade 8. Today's lesson is on the magnetic effect of an electric current. So, have you ever wondered how a lock like the one in the picture works? It's just two big pieces of metal clinging together, but there's no key involved. Now, the scientist who discovered this his name was Hans Oersted, and he already discovered this in 1820. Now, what he found was that when you have a current, an electric current flowing through a piece of metal, you can see in the picture there is a piece of copper wire, and when there is a current flowing through this piece of copper wire, this magnetic needle starts to rotate or deviates when you bring it closer to this wire through which the current is flowing. So he then discovered that when an electric current flows through a conductor, it causes a magnetic field around the conductor. Now, this can be used to make a temporary magnet. Now, what is a temporary magnet? It means that the magnet can be switched on and off. So as long as the current flows, it's magnetic, but when the current does not flow, it's not magnetic anymore. It's only temporary, it's not permanent. Now, such a magnet is called an electromagnet because it's a magnet made through an electric current. So let us look at a description or a definition of an electromagnet. An electromagnet is a temporary magnet made by winding a wire around an iron core. Now, you can make your own electromagnet. So what would you need? Number one, you will need some torch batteries or cells, electric cells, a piece of conducting wire, piece of copper wire, and an iron nail, anything made of iron that you can use in the making of your electromagnet. So how do you do that? How do you construct an electromagnet? Firstly, you wrap the wire around the iron nail to form a coil as shown here in the picture. Then secondly, after your coil is wrapped nice and tight around the nail, then you connect the one end of the wire to the one terminal of an electric cell and the other end of the wire to the other terminal of the electric cell. Now, I've made a little demonstration video for you in the next slide so that you can see what happens here. What we have here are two cells in series, a few metal pins, an electromagnet, a coil around an iron nail, and a magnetic needle. If we take a piece of wire without being connected to the cell, so there's no current flowing through this piece of wire, and I move it over the compass needle, you can see that there's not any deviation. And if you test the iron nail for magnetism and you try to pick up the pins, you will see that the pins are not really being picked up by this iron nail now. But as we connect the electromagnet to the cells, to the positive and negative terminals, and I bring it closer to the compass, you can now see the deviation of the compass needle. If I move the electromagnet around the compass needle, you can clearly see that there is a magnetic field around this electromagnet because the compass needle deviates. And when I try and pick up pins, then you can see I can pick up quite a few pins here because the iron nail is now magnetic. So you can see that it picked up a few pins, but the moment I cut the current or I open the switch, then you can see the iron nail loses its magnetism again. Because there is no current flowing and it's no longer magnetic. Now I have replaced my electromagnet. The one that I used before only had a few turns or coils around the iron nail. Now this new one has many more coils around or turns around the iron nail. Now let's see what the effect is. I still only have two cells in series, but many more turns of wires in the coil, and you can see the electromagnet is a bit stronger. It picks up more of the pins. For this last part of the demonstration, I'm still using my electromagnet with many turns of wire around the iron core. I have the same number of pins, but now I have connected two extra cells in series, so I have a total of 4 cells in series now. Let's see how that affects the strength of this electromagnet, how many pins we can pick up with this electromagnet now. And you can see it's much stronger than the one with less turns, and it's now stronger because we have
4 cells in series. If we take it to the side, and if I open the switch and the iron core loses its magnetism, then we can count the number of pins that we actually picked up with this electromagnet. Let's count them. 1, 2, 3. There's 4, 5, 6, 7, 8, 9, 10, 11, 12. We could pick up 12 pins with this electromagnet. What made the electromagnet stronger? We had more turns of wire around the iron nail, so there were more turns of wire in the coil, and we had more cells in series, so that makes an electromagnet stronger.
So let's just look at the purpose of each component in the electromagnet. We had a battery, or more cells in series, electric cells. They provide the energy for the current to flow. And then we have a coil of wire turns. And that is for the current to flow through so that a magnetic field is created. And then lastly, the iron core, the iron nail, concentrates the magnetic field around the coil to make the field stronger. So the question in the video was also, how can we make the electromagnet stronger? And firstly, we saw that if you add more cells in series, or when you use a stronger electric current, then your electromagnet becomes stronger. So if you add more cells in series, or you have a stronger current, then immediately the electromagnet becomes stronger. And then we also saw that when there were less turns of wire in the coil, the magnet was weaker, but with more turns of wire in the coil, the magnet was much stronger. And where do we use electromagnets in everyday life? In scrapyards or places where they recycle metal, you will sometimes see these huge cranes with a metal disc, and when the current is flowing through this metal disc, it becomes a magnet. It's a temporary magnet, and it can pick up pieces of metal. Now when this crane is then moved to another place and the current is switched off, the metal disc loses its magnetism, and then it can put down the pieces of metal somewhere else. And then we can also get it in house doorbells. You can see electromagnet with a little hammer, and then when the current is switched on, this hammer becomes magnetized, and it then can hit a metal dome to make a sound. In loudspeakers at the back, there's electromagnets in a loudspeaker, and then it makes the diaphragm to vibrate so that it can create a sound. The electric motor of a fan, if you have an old fan or old motor, you can open it up and you will find in there those coils of copper wire, and then that is then your temporary magnet when the current is switched on. And then also, like we said at the beginning, metal magnetic locks on doors and gates. That's also another example of where we use electromagnets in everyday life. Now the next thing that you need to do is to complete the quiz on the electromagnet and the magnetic effect of an electric current. So there's the QR code and the link. So good luck with the quiz, and I hope you learned something today.